Hello friends, welcome to Sekho. In this video I am going to derive kinematic equations for uniformly accelerated motions. So let me write it: kinematic equations for uniformly accelerated motion. Kinematic equations for uniformly accelerated motion. So here we have to remember that whatever we will do here will be for the uniformly accelerated motion. So let us say that the velocity time graph of a particle is like this: v0, initial velocity at time t equal to 0, this is time axis. Initial velocity was v0, and after some time t, let us say after some time t, this is time t, the final velocity is v. So in this case, what we have already seen in the previous video, that v is equal to v0 plus a t, where a is constant acceleration. This is what we have already seen in the previous video. In this video I'll show you two more kinematic equations. The first one is x equal to v0t plus half a t square. This will be equation number 2, and another equation I'll show you is v square is equal to v0 square plus 2ax. This is number 3. So for proving this equation, we have to remember that the area under the position time graph, this is velocity time graph, this is velocity, this is time. So the area under the velocity time graph is the distance traveled by the particle. So total area under this velocity time graph will be the total distance traveled, that means x. Okay, anyway, here what I should mention, even though these are standard notations, x is the distance traveled, or just you can say, since it is one dimensional motion, you can say that this is actually displacement, and v0 is initial velocity, a is acceleration, which is constant acceleration, and t is time. So to find total area under this curve is to find the distance traveled, isn't it? So this total area can be divided into two parts. First part is like this one, this triangle, area of this triangle and area of this rectangle. If we add these two areas, we will get total area. So what is the area of this triangle? Area of this triangle is half into this is this side of this triangle is v minus v0. Okay, this is v minus v0. So half into V minus V0 into this is t minus 0, that means t. So this is area of the triangle. So this is area of the triangle. Now what is the area of the rectangle? Okay, what is the area of the rectangle? Area of the rectangle is this side of the rectangle is V0 and this side is t, so it is just Vt. So total area under the Vt curve is total area which is actually x. This is what I have already discussed in the previous video. Even though in the previous video I have taken constant velocity and I have proved that in case of constant velocity the distance traveled is just Vt, and here it is not constant, but still it will be the area under the curve. In general, if it is any type of Vt curve, maybe Vt curve is like this, still it will be the distance traveled will be the area under this curve. Okay, so in calculus, integral calculus, you will understand this better, but we are assuming that this is true for any kind of Vt graph. So in that case, total displacement is total area. So I will add these two areas, this area and that area. So this area is half V minus V0 t, and then plus Vt. So if we simplify this, we get half Vt minus half V0 t plus Vt. So here you can see that total area is, okay, this is actually V0t. This is V0t, this much, this is V0t, this area is V0t, so this is V0t. So what we are getting is half Vt plus half V0t. Okay, so this is what we are getting, and then we can just take Vt as, okay, so here we can put the value of V from this equation 1. I'll put the value of V here. Okay, so we get like half V is V0 plus AT into t plus half V0t. So it is equal to half V0t plus half a t square plus half V0t. So half V0t means V0t plus half a t square. So x is this. So we have got the second equation. We have got this equation. So this is graphically I have done this. So this is what we are getting, and if we eliminate t from this equation, we will take t from this equation and we will put that t here, and what we get, if we take t from this equation, we will get V minus V0 by a. So let me put V minus V0 by a in this equation. So here x equal to V0 V minus V0 by a plus half a V minus V0 by a whole square. Okay, So if we simplify this, what we are getting, v0 into v by a minus v0 square by a plus half a. Let me take this v0 out, so it will be by a square, v minus v0 whole square equal to v0 v by a minus v0 square by a plus half 1 by 2a. Let me write it 1 by 2a, v square minus 2v v0 plus v0 square. So if we simplify this, what we are getting, v0 into v by a plus v0 square by a plus 1 by 2a. Okay, let me just simplify it, v square by 2a minus v0 by a plus v0 square by 2a. Now you can see that this and this will cancel out. So what we are getting is here v0 square by a, and here it is negative sign, and here v0 square by 2a. So what we are getting is v square by 2a minus v0 square by 2a. Okay, from if we combine these two, we will get v0 square by 2a, and in this side we have x. So if we take 2a common and then multiply this in this side, we get v square minus v0 square equal to 2ax. I think you are smart, you understand at least this much. Okay, I don't know whether it will be problematic for you. I have just jumped on a step. Otherwise, in my case, what I would have done is I would write this and maybe one line, and then finally I will write the answer. Okay, I don't write this much for myself, but I thought that it may be confusing for you, so I am writing all this. So we have got equation 3 also, v square equal to v0 square plus 2ax, equation 3. So this is how we can find these three very important kinematic equations. There are some other ways to think about this also. Let me show you how to think it in some different way. Actually, if you are following my videos, you know that I am following NCERT books, but if you are reading NCERT books, you will know that I am not just copy pasting from NCERT books. I am putting my understanding, and sometimes I try to give anything extra that I think will be helpful for you to understand it in a better way. That means I am giving NCERT through my perspective. Okay, what I understood and what else can be said about it to understand it better. What I feel, I share with you. So sometimes I give something extra, and this is also something extra, even though they have talked a little bit about it, but they have not exactly said what I am going to say. Okay, so you can think about this like that. This is time t, this is time t, this is 0, this is v0, and this is v. Now the velocity in the middle of these v0 and v is, what is it? It is v0 v plus v0 by 2, and it will fall in the middle of this time 0 and t. It will be t by 2. Why? Because it is a straight line and it is constant. It's a straight line. Okay, so if you take middle of this, you will get middle of this gap, isn't it? It is, use your common sense and you will feel that. We can prove it, but we don't need to prove here. You just can intuitively understand it. If I take middle of this, you will get middle of that. Now in this side you can see that velocity is increasing, and in this side with respect to this point velocity is decreasing. अब इस तरफ जितना वेलोसिटी इंक्रीज हो रहा है, जैसे इंक्रीज हो रहा है, इस तरफ उतना ही वेलोसिटी डिक्रीज हो रहा है, और उसी तरह से वेलोसिटी डिक्रीज हो रहा है. ये स्ट्रेट लाइन है ना, तो इधर जितना वेलोसिटी इंक्रीज हो रहा है, इधर उतना ही वेलोसिटी कम है इससे, है ना. तो इसका जो एवरेज वेलोसिटी, वी कैन से दैट इट्स एवरेज वेलोसिटी इज v plus v0 by 2. We can say that average velocity is v plus v0 by 2. इसका मिडिल वाला जो वेलोसिटी है वही एवरेज होने वाला है. क्यों? क्योंकि इधर जितना इंक्रीज हो रहा है, इधर उतना ही डिक्रीज हो रहा है. इसीलिए इसका एवरेज वेलोसिटी विल बी v प्लस v0 by 2. अब ए अगर एवरेज वेलोसिटी है v0 प्लस v by 2, तो इसके साथ अगर टाइम को मैं मल्टीप्लाई कर दूंगा तो हमें क्या मिल जाएगा? x मिल जाएगा, है ना, x मिल जाएगा. अब क्या करेंगे हम? वो जो फर्स्ट इक्वेशन हम लोगों को इससे पहले वीडियो में मिला था, v इक्वल टू v0 प्लस at, वहाँ से हम लोग यहाँ पे v का वैल्यू पुट कर देंगे. तो क्या मिलेगा? v0 प्लस v प्लस at by 2 into t. So it will be, this is v0, so v0 plus v0 plus at by 2 into t, इसका पूरा का साथ t का मल्टीप्लिकेशन है. सो यहाँ पे 2v0, सो बाई 2, तो ये हो जाएगा v0 प्लस हाफ. अब t इधर ये t मल्टीप्लाई होगा, हाफ a t स्क्वायर, इजंट इट. सो x इक्वल टू दिस, ये मिल गया हम लोगों को इक्वेशन नंबर 2. सो एवरेज वेलोसिटी के साथ अगर टाइम मल्टीप्लाई कर देंगे तो हमें ये मिल जाएगा इक्वेशन नंबर 2. बहुत अच्छे से मिल जाता है इजीली. और अगर यहाँ पे हम लोग t के जगह यहाँ पे t निकल लेते हैं, v माइनस v0 बाई a, ओ पुट कर देते हैं, तो हम लोगों को इक्वेशन 3 मिल जाएगा. यह है इक्वेशन नंबर 2. यहाँ पे अगर ये t का वैल्यू पुट कर देंगे तो क्या मिलेगा? x इक्वल टू v0 प्लस v बाई 2 इंटू v माइनस v0 बाई a. सो यहाँ पे 2a कॉमन ले लिया, 2a, तो रह गया v0 प्लस v इंटू v0 v माइनस v0. इसका मतलब क्या है? इसका मतलब 2a को इधर लेके आते हैं तो ये होता है 2ax इक्वल टू v स्क्वायर माइनस v0 स्क्वायर, इजंट इट. a प्लस b इंटू a माइनस b, सो v स्क्वायर माइनस v0 स्क्वायर. So we get v square equal to v0 square plus 2ax. We have got equation number 3. So this is quite simple. Now यहाँ पे आप लोगों को शायद ऐसा दिमाग में आया होगा कि अगर एक कॉन्टिन्यूस ये कांस्टेंट एक्सीलरेशन नहीं होता, अगर ये स्ट्रेट लाइन नहीं होता, ऐसे होता, अगर वेलोसिटी टाइम ग्राफ ऐसा होता, तो भी इनिशियल वेलोसिटी v0 ही होता और फाइनल वेलोसिटी v ही होता, है ना. फाइनल वेलोसिटी तो वही है, अब फाइनल वेलोसिटी वही है और इनिशियल वेलोसिटी भी वही है. तो तब क्या एवरेज वेलोसिटी v प्लस v0 बाई 2 हो सकता था? तब क्या ऐसा होता? बिल्कुल नहीं. तब एवरेज वेलोसिटी ये नहीं होता, क्योंकि अगर ये एवरेज वेलोसिटी होता तो इसके साथ टाइम मल्टीप्लाई करने से हमको एरिया अंडर द कर्व मिलना चाहिए, लेकिन इसका एरिया अंडर द कर्व देखिए, इसके एरिया अंडर द कर्व डिफरेंट है ना, इसका कम है। मतलब इस कर्व में जब पार्टिकल मूव किया, मतलब जिसका वेलोसिटी टाइम ग्राफ ऐसा है, उसका डिस्टेंस और कम ट्रैवल किया है ना। लेकिन एवरेज वेलोसिटी अगर ऐसा ही है, टाइम भी उतना ही लगा, तो एवरेज वेलोसिटी से मल्टीप्लाई कर देंगे तो वही तो मिलेगा ना जो इसमें मिला है ना। तो तब तो गलत हो गया, ये तो कम है। सो दिस इज ट्रू, all these equations actually are true only for when a is constant, and this idea is also true that v plus v0 by 2 is average velocity. This idea is true if this is actually constant acceleration. Okay, the increment of velocity is constant. Okay, that's why it is working, otherwise it will not work. Now all these things can be done in some different way. We can use calculus for doing all these things. So first of all, we can start with definition of acceleration. dv dt means acceleration, isn't it? I have already discussed this in the previous video. So dv is equal to a dt. Now I have to actually assume that you guys have already started to learn calculus. If you don't know calculus yet, you just follow how to actually deal simple problems, and then slowly you will learn calculus. Okay, so we can do this. You just know that we can just we can think like dv by dt is, this is like derivative, this is division of dv and dt. So we can multiply a by dt, and then you can think like that. For our purpose it will work. So this is integration sign. We are integrating from v0 to v, and here t0 to t. That means when v changes from v to v, similarly this variable t changes from t0 to t. Now when we do integration, what happens, of some dv only, we get v. Okay, and we have to write limit like this, v0 to v equal to, a is constant, so it will come out of integration sign, and then we will have just t and limit t0 to t, and I have written in third bracket. That means I have to put these limits. So I will put the upper limit first, that means this one v, then minus lower limit. I have to put the lower limit in the place of v, so it is v minus v0, and a, I have to put upper limit first, t minus t0. So what I have got is v is equal to v0 plus a t minus t0. Now if I assume that t0 is 0, that means when we have started to observe, it is 0 time, our clock shows 0 time, then it will be v0 plus a t. Actually that equation which I have used, in that case we have assumed that when initial velocity was v0, initial time was 0. Okay, so we have got equation number 1, isn't it? Now we want to get equation number 2. So what we have to do in for getting equation number 2, see, again we write dv dt is equal to a, and we can manipulate this like dv dx and dx dt. You can think like I have divided by dx and then again multiplied by dx, so it will remain same, is equal to a, and so this is again v, so dv into v equal to you multiply this dx in this side, so a dx, so v dv equal to a dx. So we will integrate both side, so we can integrate both side. V goes from v0 to v and dx goes from 0 to x. Okay, so in this case, when there is power on of this variable with which we are integrating, so its power will increase by 1, so v will become power is on plus increased by 1, then this power will be divided, so it will become by 2. Then we have to put the limit v0 to v, so 1 plus 1, I will write this just 2, so I will write this 2. So this is just 2 equal to a x, and I have to put the lower limit and upper limit. So if I put this upper limit here, what I get is v square minus v0 square by 2 equal to a x. So I get v square equal to v0 square plus 2ax. So I got equation number 3. Now how do I get equation number 2 here? In this case, what I have to do is, we can write v, okay, in this case I can just continue this with this one. So if this is equation 1, this means dx dt is v, so dx dt is equal to v0 plus at. So I take dx and dt in that side, v0 dt plus at dt, integrate both side. This will go from 0 to x, t will go from 0 to t will go from 0 to t. So this will be, this side will be x, this will be v0, v0 is constant, so here only t, plus here we will get a t square by 2. So we get x equal to v0 t plus half a t square. This is equation number 2. So we have got all the 3 equations just by using calculus. So in this video I have derived all the kinematic equations for constant acceleration, and in next video I will do some examples, and then I will move forward in this chapter. If you guys like these videos, if you have learned something more than what is given in the NCERT, or you have understood better, it helped to understand NCERT's better, then please subscribe this channel and also hit the like button. Thank you for watching. I'll see you soon in the next video.